Right, so going through the test. So the first, quite a few people, the first one was generally okay. The second one wasn't too bad. So most people got to this point, okay, and they got a mark. But then they went horribly wrong. Okay, what does this say? This says x divided by 7 equals 10. How do we undo something? We do the opposite, and what's the opposite of divide? Times. So you had to multiply both sides by 7, didn't we? Remember? And that gave us 70. Okay? Because remember, always the answer you get here, you need to be able to stick back into the beginning to get the right value. So if your value here was a fraction, dividing it by 7 and taking 4 wasn't going to give you 6. So always try and remember the aim of the game and what it actually means, what your answer means. And the next one was 48. Generally that was fine. So part 4, a similar situation here. So essentially people were struggling with the dividing aspect. So x plus 9 all divided by 4. So remember this line underneath implies that there's essentially a bracket around the x plus 9. So we have to deal with that 4 first of all. So we have to first of all multiply both sides by 4. Okay, because that got rid of that. And then you subtract 9. Okay? So it gives you 39. Good question, or you were telling me? Next one, so we had x on both sides, numbers on both sides. This was done quite well. Ended up with x is 9. And the last part in this one, what's the first step? When we see brackets, we have to do what? James? Not simplify, special words. Expand brackets. Yeah, so expand the brackets, get rid of them. And you've got to remember that both of the numbers inside the bracket are multiplied by the value. So that's where some people made an error there. Okay? And that one ended up with x equals 37. Alright, so there's those solving equations. Number 2. Here is the sequence. So lots of you, bless your little hearts, you spotted that the numbers were going down by 2, and you wrote minus 2 for all of them, and then you circled the first one. Okay? And remember, if it was going down by 2, then it would be minus 2n.
What number are we on, Barry?
We're on number 2, darling. Okay? So it had to be minus 2n because it was going down by 2. So we're now out of the last two options, either this one or this one. Okay? So we know it's got to be minus 2n. Well, our sequence started at 15, but remember, to find an n number, what do we have to do? We have to say, what would the number have been before it? And so our number would have been before that would be 17, and this is equivalent to this one. Okay? So it would have been the 17 minus 2n. Okay, lots of people got that, which was great. Here's a linear sequence. The first 2 terms were missing. So the first 2 terms were missing. Okay, so it didn't start at the number 3. There were 2 terms before it. Describe using words how the sequence is formed. Well, how have you got from a 3 to a 9? What have you done to it, Georgie? Added 6. Yeah, so I was looking for you're adding 6 each time. Okay? So the next one, B, says what's the first term of the sequence? Well, if we had gap, 3, 9, 15, etc., we knew we were adding 6, how would we work out this number? 6
times 1, 9.
Oh, you worked out the rule.
Oh, yeah.
Okay, well, even easier than that, we could just work our pattern back, couldn't we? Yes? So if we were adding 6 each time to these ones, we could take away 6, couldn't we? Yes? So what's 3 take away 6? Negative 3. And then we could take away 6 again, which gives us negative 9. So our first term in our sequence was negative 9. Okay? It then says what's the nth term rule. So we know we're adding 6 each time. So that means it's 6n. and then we find out what would the one value before it be. So we have to take away another 6. What's negative 9 take away 6? Really negative 15, yes. So it's 6n minus 15. So you've got 1 mark for identifying the 6n and 1 mark for the minus 15. Okay. Next one, there was just one value you had to fill in. I think everyone got that. It's negative 6. That's great. And then you had to plot the points. You should join them up, ladies. Okay, I did give them up even if they weren't joined up. So you should join them up because it's a graph. Okay, it wasn't an actual sequence, it was a graph. So I gave it to you anyway. Right, so number 5. So number 5a was similar to that one at the beginning. So what should the answer to 5a be? How do we do it? And squared? X equals 50, good girl. So we had to multiply both sides by 10. 5b, you have to rearrange, and solve that. And you ended up that y was 27 divided by 2. You could have left it like that. Or you could have put the decimal value, which was 13.5. Remember, they can be decimals, and they don't have to be whole numbers. Yes. Oh, okay. The next one, we had w's on both sides, so we had to rearrange. And we ended up with 10w equals 17. So what did w equal?
17
Yep, 17 divided by 10. Again, you could leave it like that. Or you could have worked out the decimal, which was 1.7. Yeah,
That's what I wrote and I got never.
you got a method mark. Okay, so if you've got 1m or m1 anywhere, I've given you method marks, but there was, something went wrong that you didn't get the right answer. Okay? So that one was after 3. Alright, number 6 we're on now. So which of the lines has a gradient of negative 2? Right, which of these ones can we wipe out straight away? Abby, which ones can we wipe out straight away?
What are facing, like from the bottom corner to the top right?
Yeah, so which letters are they?
Those are P and R.
Okay, so we're ditching P and R.
Because they're positive.
So it's either, exactly, they're positive. So it's either Q or S. So then we have to remember how do we find the gradient? Gradient is equal to what over what? Madison, do you remember what's gradient equal to? No, nothing coming back to you for the lessons? Something over something. So both begin with the letter R. Good girl. Say loudly. Rise over run. Perfect. So rise meant how many we go up, and run means how many we go across. Yes? So our rise for the Q, we know it's negative, and our rise was 2 and our run was 4. Now, negative 2 over 4, is that 2? No, it's negative 1/2. And S was rise, we knew it was negative 4 and 2, which is negative 2. So you should have circled S. Okay? 7a. They've told you the rule. They've told you it's n plus 6. So if they want the first 3 terms, we have to find the first term. What value do we know? Good. 1 in place of the... Good. So it's n plus 6. So the first term will be 1 plus 6. The second term, how would we find the second term, Madison? How would we find the second term? You're going to do the board, sweetheart. So we knew that the first term was, pardon? 2 plus 6, here we go. And the third term, n squared? 3 plus 6. And now we find the answer to those. What counts? You can't do it. 1 plus 6 is? 7. 2 plus 6? 18. 3 plus 6? 9. There we go, 7, 8 and 9. That's what we were looking for. Okay, unfortunately it was 1 mark, all 3. So all 3 right to get the mark. We've got a new term, a new sequence. So this one is oh no it's not, it's 45 take away 5n. Principle is the same. Okay, so for the first term, we're going to say 45 take away 5 lots of 1. Second term, 45 take away 5 lots of 2. Third term, 45 take away 5 lots of 3. So we're just substituting n as 1, then 2, then 3. So you've got your calculators, so you can use those to help you. Those values are 40, 35, and 30. Again, 1 mark for all three of them, right? So sorry, I'm not sure you got the first one as 40, and then something went wrong with the others. Alright, solve the equation. So we had a bracket on one of the sides, we had to expand that. Remember, everything has to be multiplied by that number, rearrange, and you get a value as 7 over 3. Again, as we said, it doesn't have to be a whole number, and often better to leave them as fractions rather than try and write decimals, but it's fine to write it as a decimal. Number 9. Think of a number, I'll multiply it by 3 and subtract 1. The answer is 14. The very first few words of this sentence is very important. It says, write an equation and solve it. Okay? So, writing the answer was no good. You had to write the equation. So we did stuff like this. We had words. We had to form an equation for it. I think of a number. I'm going to call that number n. I'm going to multiply it by 3. Abby, how do I show that that number has been multiplied by 3?
3n.
Good girl. 3n. And subtract 1. What do I write now, Maya? Into it? I'm going to subtract 1. 1's 1. Yeah, it wasn't true. The answer, Georgie, the answer is 14. What do I write now? Equals 14. Have I formed an equation? Yes. 1 mark. Okay? So then 1 mark for the equation. 3n, take away 1 equals 14. You had to have that. Then you rearrange and solve it. You find that n was 5. Okay? So that was the number we first thought of. Number 10, here are the first 4 terms in the number sequence, 5, 8, 11, 14. Casey thinks the number 34 is in this sequence. Is Casey correct? Well, the best way of doing this, so 5, 8, 11, 14. So we had some of these in the review that I gave you. The best way of doing these kinds of things is to find the rule for this. Okay? So if we can find the rule for this sequence, then that's going to help us. So, Max, how do we find a rule for a sequence? What's the first thing you have to do? Do the difference, yes. And what's our difference in here? Good go. So 3. So my rule is going to start off, Maya, how? 3n. Lovely. And then, Jade, what do I do to find the end portion?
To divide by 3. Oh,
Not divide by 3.
Here, the next is 3 minus 3.
You're going to take away 3, good, because we're going to see what number would be before it, and what would that be?
2.
And so it's going to be 3n plus 2. So our rule for this sequence is 3n plus 2. Okay, this is the easier way of doing this. So if this is our rule, and Casey thinks that 34 is in the sequence, it would mean that if we were to show that 3n plus 2 is equal to 34, if we were to solve this, if we get a whole number for n, it means that it would be in the sequence. But if we get a weird number for n, it means it's not in the sequence. And if we solve this, that's not a whole number. And so it's not in the sequence. Okay. Now, I may have accepted your response as legitimate. I couldn't accept things like they had to be odd, even. I couldn't accept that it was a multiple of 3 because 5 is not a multiple of 3. So there were certain things I could accept and certain things I couldn't. Okay? So if you have a question about your marking of it, the marking I've done of yours, you come and see me afterwards. You have a question?
No.
Okay. Number 11. So we're on number 11. Find the gradient. Oh, this one was gutting. Gutting, ladies. Gutting.
Because it was a decimal point, Dina.
But it wasn't, because if we have a look now, lots of you counted, see the picture? Oh, this is a rubbish diagram. So there was the graph, and this went up here like this. This one here wasn't a whole square. Can you see that? Look at your picture in front of you, this is my rubbish. Okay, so if you look in front of you, that bit wasn't a whole square, so you couldn't count that as a square. So you either had to start counting here, just below it, for your rise and your run, or anywhere along here that you could actually count the number of squares. Do you all see that? Because lots of you wrote 10/7, I think it was.
So I thought we had to do the lower part. I thought we had to go through there, not through. I thought we had to start from there. No.
Which way you had to start from there?
I thought we had to start from there.
Yeah, but what I'm saying is that this isn't a whole square, so you shouldn't have counted that. You should have stopped at that one. Pardon? Well, the answer is 3/2. Maybe it was 9/4, did some of you have? Some of you have 10/4. I don't know, what did you have?
I had 10/7.
You loads of you had the same answer. 10/7, okay. So it shouldn't have been 10/7 because they weren't whole squares that you were counting. Okay? So when you're counting your rise and your run, it has to be whole squares that you can see. Do you see that now? So can we look at our diagrams now and see if we can see what I'm talking
I
about?
got 3. Is that it?
Right.
It's all against nobody else. Scratch. Like,
I'll scratch you on it. Come on, we're videoing. Right, number 12, next one. This was done very well. And so pattern number, check. Complete the table, 9 and 11, check. How many sticks make pattern 15? To be honest, it was probably easier to find the rule, so it was probably easier to find part D before you found part C. And so how do we find the rule? Well, our sequence is 3, 5, 7. That's the bit they gave us, just in case we got something wrong. So we said we found the rule by finding the difference. So that's 2. So we know it's going to be 2n. And then how do we find this bit? It's a +1. So that's our rule. So that was part D. And if we want our 15th pattern, it would be 2 lots of 15 plus 1. So it was 31.
I got 45, I got 5.
Can't help you there, darling. Especially if you got that one right, Diana. Right, number 13 was done very well. Stick the numbers into the calc. 4, take away -1 was 5. So the numbers in the table should have been 5, 4, 3, 2, 1, 0. Plot those points and draw them up. Lovely job, a nice 4 marks.
The next one.
The extension. Okay, so the extension.
Yay.
So remember, this is where we're going to have to start applying some of our understanding. So they said the nth term of sequence A is blah blah, and B is blah blah. Work out 2 terms that are in both sequences. So you just had to go through each sequence and write some numbers in it. So for sequence A, going through the substituting 1, 2, 3, 4, you would have got 5, 7, 9, 11. Do we see the pattern?
13.
We're adding on 2, so 13, 15, 17, 18, 21, 23. So we could keep going forever. Let's do some B's. So B would have been 1, 6, 11, oops, 16, 21, 26, and so on. And then we all just have to look to see what numbers are in both patterns. So 11 was, and 21 was. Okay, so there's our 2 numbers that are in both sequences. Okay? So there's our 2 numbers that are in both sequences. Number 15 is, you could have had any answer in the whole wide world for this one. It says work out coordinates of any 2 points that lie on the line. Now, do you remember for stuff like this, number 13, we were working out coordinates, weren't we? Yes? So for number 13, these values here were coordinates that you plotted. And like, 99% of you, maybe all of you, got this right. Okay? So you knew what you were doing here. You knew you were finding coordinates. So how did you do that? You just chose values for x and stuck it in the value, didn't you? Yes? So what are you going to do for this? You're going to choose values for x and stick them in to find the y value. Okay? So you could have had lots and lots, every one of you could have had different answers here.
That one really confused me. I'm still confused. Why am I getting wrong?
So, what did you hear what I said? Were you listening to me?
Yeah.
So, what were we doing here for number 13? Did you get number 13 right?
Yeah.
Yeah, pardon?
Yeah.
Yes? So, what did you do here? How did you fill this table in? And what did it represent? So, it was -1 and 5. How did you work out this value was 5? You were told the rule, weren't you?
Yeah.
Yes? So, how did you know this was 5?
4 take away 1.
4 take away the -1.
Okay.
Yes? And then, what made you, how did you draw then your graph?
Why is it 4?
Okay, so this was now a coordinate, wasn't it? Okay? So these, listen to the words I'm saying. So we use this rule to find this value,
Oh,
and this gave us a coordinate.
was this relating back to that question?
No, it's nothing to do with this question. What I'm trying to explain to you is that this is how the application section works. Okay? You were able to do this question, and you knew that these represented coordinates. Yes? So to find a coordinate, you just choose a value for x and substitute it in. So for question 14, the rule was, no, not totally not 14. Where are we? For number 15, the rule was y equals 12 take away 5x. Okay? So you could choose any value for x here and substitute it in. So if I would chose x as 1, it would be y was 12 take away 5 lots of 1. And so y would be 7. So a coordinate would be 1, 7. That's one coordinate. If I chose x was 2, I would say y equals 12 minus 5 lots of 2, which is 12 minus 10, which is 2. So that would be the coordinate to 2. You could have chosen x is 350. You would have y is equal to 12, take away 5 lots of 350. Well, that was a bit silly comparison because I don't know what that is. Let's choose a smaller number, 50. 5 lots of 50. So you would have 12 take away 250, which is -238. So my coordinate would be 50, -238. Okay, so to find a coordinate, you are substituting in any value of x that you wish to into their rule. Okay, so as I said, you could all have had completely different answers.
Did we learn that? Yeah.
Something, that's what I'm trying to explain to you. We learnt how to draw these, didn't we? And you did that, so you knew that this was a coordinate. Yes? And so that's applying it to this stuff. That's how it's an application. Right?
I don't understand why that. Because I did the 1, 7, and the 2, 2.
I think you just didn't stick it into here properly. Because then you've got +2, I think. So we'll sort it out in a second. Jay? Oh, hurry up, please. Right, number 16. The nth term of the sequence is 7n minus 3. Work out the first 3 terms. I think this was done very well. 4, 11, 18. So you just stick the values in. And which term of the sequence has a value of 109? So if you know that the sequence is 7n minus 3, and you know that the term you're looking for is 109, you're going to form an equation. Okay? So you're going to write that 7n minus 3 equals 109. So this is 16b. And so that means that 7n is 112, and n is 112 over 7, which is 16. So it's the 16th term. Okay? Some of you were sticking 109 into n, so you misunderstood what they were asking. Right, number 17, I ditched from our total, so not to worry about that, but I will go through how we would do it. Now, I know some people asked Dr. Fato what consecutive meant. Did he tell everyone?
No, he didn't tell me.
He told us that one we had to test. Oh, right, okay. So, does anyone know what consecutive means?
I didn't hear that either.
3 numbers in a row. Okay? Apparently he told you when pages were handed in, so it wasn't like he announced it to anyone. Okay? So it means numbers in a row. Okay? So if I said that my first number was n, if I wanted a number after n, straight after n, how would I describe that?
+1.
N plus 1. Absolutely, Abby. Yes? Do we understand that? So if I chose that my number was n, then the one directly after it would be n plus 1. What would the one directly after that be? N plus 2. Exactly. Are we happy that they are consecutive numbers? And remember, this could be anything. Okay? But this is the one that's going to be directly after it. This is the one that's going to be directly after that. Okay, so n plus 1, n plus 2.
Wait, what did you do +1? Why did you do +2? Sorry.
Because that's going to be the one after this one.
Wouldn't it be 2 after n, essentially?
Yes, that's what n plus 2 means.
But it wouldn't, I mean, it would be the one after that, but why can't you write n plus 1 again? Because you would have found that value, like for n plus 1.
No, sweetheart, we don't know that value yet.
So, like, you wouldn't, so like, if it was like 5, so like 5 plus 1 is 6. And then 5 plus
But
another.
we don't know what that number is yet, do we?
No.
So we have to show an expression for each of the numbers. So n, n plus 1, and n plus 2. We don't know what they are. That's how we would describe them. Okay? But we're told that the sum of those 3 numbers, what happens when we're finding the sum of things? We add them. So the sum of those 3 numbers is 162. So the sum of those 3 numbers is 162.
Oh, wait, I have
So-
a question. I think I know how to do it.
That's not a question then, is it?
Well, no, but what?
So then what would we do? We've got lots of letters and lots of numbers. What do we normally do to those things? Madison, what do we do? We have lots of, pardon? Not subtract. We've got n plus 1 plus n plus 2. Look, same letters. What could we do with them? We're going to simplify it, okay? How do we simplify that? You've got an n here, and you're adding another n, and you're adding another n. You're not sure? Anybody? Good girl, 3n plus 3. So what we're doing is we're joining like terms. So we've got n plus another n plus another n. So that was the 3n. And then we've got plus 1 plus another 2. It gives us plus 3. And then we've got a nice equation that we can solve. So we're going to subtract 3 from both sides. And divide by 3. Okay, so that gives us 53. The question does say find the 3 numbers. So the 3 numbers would be 53, 54, and 55.
I thought that, but I really don't want to.
Because you didn't write an equation.
I just did all these.
You didn't write an equation. It says write an equation and solve it. And number 18. Oh, girls, we went through stuff like this. Lots of you came to ask me. I did it on the little green, the whiteboard at the back.
I ran out of time.
So, the length of the rectangle is 5 centimeters longer than its width. So you had a diagram with x there. How would we label this bit? X plus 5, because it's 5 centimeters longer, if the perimeter is 42, find the dimensions. So if this was x plus 5 and this was x, the perimeter, we know to add them. And we were told that it was 42. And just similar to the one above, we're going to join like terms. So there's 1, 2, 3, 4 x's plus 10 equals 42. 4x equals 32. That's really annoying for this word. So x is 8. It does say find the dimensions, so that means you need to give both of them. So if x was 8, it means that this value here must be 13.
I was going to say 9.
Okay, so the dimensions was 8 by 30. Alright, so this is the test.